everyone, we're going to sketch the region enclosed by the curves and integrate with respect to, for us it's going to be y, and find the area of the region. So this one's a bit of a hard one. Let's see if there's any intersection points. So since we have x equals x, let's do y squared minus 4y equals 2y minus y squared. You add y squared to both sides, you get 2y squared, and subtract 2y, you get minus 6y equals 0. Let's factor out a 2y, and that's going to give you y minus 3 equals 0. So we have y equals 0 and y equals 3. Now when y is 0, our x is going to be 0. And when y is 3, we're going to get 2 times 3 minus 9. So it's going to be negative 3. So those are our intersection points, and that's going to be helpful. So let's do that part. We got that done. Now let's see if we can kind of look and see what we have. All right, so there's the sketch. It's going to intersect our two curves at 0, 0 and negative 3, 3. Somewhere in here. All right, now we have to sketch the curve. This is a parabola, and it's going to open up to the right because it's positive. So if we have, let's complete the square. We have x equals y squared minus 4y. Complete the square, you add 4 to both sides. And this is going to give you x equals, condense this to y minus 2 squared minus 4. So your vertex is going to be at y is 2, x is at negative 4. So right about there. All right. Let's see. And your y-intercept would be when x is 0. Let's don't worry about that. So basically it's going to open up this way. And it's going to go through this point here. So that's that one. Now let's do the same thing for the second one. The second one is going to open up to the left because it's negative. So I'm going to rewrite this and just write negative y. Let me scoot this over. All right, sorry. X equals negative y squared minus 2y. Now you complete the square. You're adding 1, and you add 1. You're going to subtract 1 here because it's minus the 1. So you're going to get x equals negative y minus 1 squared, and then you're going to have plus 1. So this is going to be at 1 and 1. All right. And again, we already know the intersection point, so we don't have to worry about too much more. So this is going to go this way, and this one's going to go like this. All right, so that's just our little sketch there. The area we're looking for is right here. All right, so we're going to integrate with respect to y. So we're going to go from 0, and this is to 3, 0 to 3. So the area is going to be equal to the integral from 0 to 3. Now we want to do right to left. So when you're using, we're going to have to subtract these two, and you want to do right to left. So the right part is enclosed by this one. So you write this one first, 2y minus y squared. And then the left side is enclosed by the green one. And the green one is this one. So you're going to subtract y squared minus 4y. And then this is dy. All right, dy. Now that we have that, the rest should be kind of easy. Let's see what we get. Let's clean this up a bit. So we're going to get the integral from 0 to 3, And this is going to end up being negative 2y squared plus 6y dy. All right, we're going to integrate that, and that's going to give us negative 2/3 y cubed plus 3y squared, and we're evaluating it from 0 to 3. I don't know if I want to squeeze all this in here. I think I can. When you substitute in the 0, it's going to go away. It's just going to go to 0. So if you substitute just in the 3, that's all we have to do. We're going to get negative 18 plus 27. And then we're going to have that minus 0 for this piece. So our area is going to equal 9. And that's it. Thank you. Have a nice day. Bye-bye.